Hello friends, welcome back to Learn with Ansh. My name is Ansh and in this video we are going to be discussing about distance and displacement. So how do we define distance? Distance in simple words is the actual path of motion or the actual length of motion. Distance is a scalar quantity. We've discussed about scalar quantities and vector quantities in our previous video, and distance is a scalar quantity. That means it has only magnitude and no direction. Let's take 2 points, point A and point B. To travel to point B from point A, I take this weird path. Distance will be the length of this path. What about displacement? Displacement is the shortest path of motion, essentially the distance between the final and initial point. Displacement is a vector quantity, that means it has magnitude and direction. Again, taking point A and point B, this was my original path. Distance will be the length of this. However, displacement is the shortest path between the final and initial point. Right? So this yellow arrow will be our displacement, which is the shortest distance between final and initial point. This table will give you an idea of the differences between distance and displacement. Distance is the length of the path traveled by the body. Displacement is the shortest distance between initial and final point. Distance is a scalar quantity, that means it has only magnitude and no direction, whereas displacement is a vector quantity. It has both magnitude and direction. Distance is always positive or zero, whereas displacement can be negative, positive or zero. There is always some value for distance if there is motion. However, displacement can be zero with motion if the body shares initial and final point. The SI unit for both distance and displacement is meter. Now that we are clear with the difference between distance and displacement, let's see if we can solve the problem. The distance between your school and your house is 2 kilometers. This is assuming everything is in a straight line. You go to your school and come back. What is the distance? Well, going is 2 kilometers. Coming back is 2 kilometers. So the distance must be 4 kilometers. What about the displacement? Let's see. The initial point is your home. The final point is also your home. And we know if the initial point and the final point of a body in motion is the same, then the displacement, no matter how much distance it covers, will be zero. Let's have a look at another example. Let's say I'm going in this direction for 3 meters. Let's call this motion A. Then I take a turn at exactly 90 degrees and I go in that direction for 4 meters. Let's call this motion B. What will be the displacement? Well, if you have a look at this, the displacement, if we draw the arrow for displacement, it will make a right angle triangle. So we can use Pythagoras theorem to figure out what will be the displacement. And the displacement will be in this direction with a magnitude of 5 meters. Alright, the final question for the day. The question says that I am running in a circular track and I run for half a circle of this circular track. If the value of the radius of this track is capital R, find the distance and displacement. The hint is on your screen. The white colored dotted line outside the track is the distance and the yellow colored dotted line is the displacement. Now can you calculate the distance and displacement? I'm going to give you some time to try this out yourself. I'm assuming that you had a go at it. Here is the solution. The distance will be the circumference divided by 2, that is pi r, where r is our radius, so it will be capital R. The displacement is the shortest path, and if you can see, the displacement is nothing but the diameter of this circular track. So the displacement will be 2r. I hope with these examples the concept of distance and displacement is clear to you.